Yeah, good evening, everyone. So, in the last video, I think we are discussing linked list, right? How to represent the linked list. So, even in the diagrammatic manner, we have seen, and I think we are preparing some programs related to that linked list, right? So, how to create a linked list up to that, I think I have explained, but still there are few more functions that we need to implement in this. Okay, basics of linked list. So let me revise for 1 or 2 minutes. So this entire part is nothing but a node. So we know very well in every linked list, we have to create a node. This node consisting of two parts. The first part is always called as a data part, and this part is always called as next field. Okay, like that we have two fields will be there. Now, so if you want to add any object into this, okay, you have to create the node and you have to make appropriate links. Okay, so I explained very clearly in the last video how you can able to add a list into beginning. So for example, consider this is my list. Initially, my list is empty. So your head pointer will always point to null. I want to create this new node. NN is nothing but new node. Okay, so what is the data? Let it 10, and this pointer is always pointing to null. So what is the name of this node, sir? New node. Now is head is equal to null? Yes, head is equal to null. Then this node will become hen, that means head node. That's all. This is one case. Suppose consider on this I want to add one more element at the first, one more node. So this node is already there, right, in the linked list at 10. The next field is null. The name of this node is nothing but head node. So this is nothing but new node, whatever we have created. This is null, and let it be this value is 5. Now, is head is equal to no null? No, head is already pointing to something. It is not equal to null. Then what will happen? Your head will become new node in the previous case. But now new node dot next. In the new node next field will be there. So that is previously it is null. Now what I am doing? I am removing this null. Now I'm pointing this one to head node. Head node is this one. So this link is pointing to this one. After that, your head will become new node. This will become head node. That's all. Now, previously where head node is available, this node will be gone. That's all. Okay. Like suppose if you want to create one more node. So one more node will be created here. So consider next field is null. This field is 2. And what is the name of this node? New node. So now is head is equal to null? No, it is pointing to some node. Then new node tends to next. Already new node tends to next is null. Now that one is pointing to this one. Next, what will happen? This will become head node. So once if head node is pointing to this head node will be gone. Right? Like this, we have seen how this add first function is going to work. Now we need to see how to print the elements, because that is very, very important task, sir. Okay, that's why I skipped last week. Okay, I need to complete this print list function. Then we will go with add last line. Can you please confirm? So up to this, whatever I explained, just like a revision, is it clear for you people, guys? Please respond, friends. Yes, everyone, please confirm. Clear? Right. Sir, this one is somewhat complex. I request everyone to please put more concentration. So I want to print the elements in the list. Sir, print list I am taking. Okay. If head is equal to null, then we know that list is empty. Okay, fine. Suppose if head is not equal to null, means what? There is some some nodes are there. Okay, we have to retrieve the nodes one by one. Sir, how to retrieve the nodes one by one? I'm going to create one temporary node. Any node you can take. For example, node temp is equal to I am pointing head. So parallelly, I will take the diagram also. so that it can be very easy for you to understand the code. Now listen carefully, friends. So consider previously I have created one list, right? So linked list, this is the 2. This next field is pointing to something like 5, and this next field is pointing to something like 10. Like that, we have created this one become null. This entire thing is addressed by head, right? Now I'm creating one temporary node. I will represent this temporary node with another color. So TN temporary node, okay, TN temporary node, which is pointing to head, because we should not disturb a head node. I am pointing this TN temporary node. Is it equal to null? No, it is not equal to null. So I am checking because I don't know how many nodes will be there. While your temporary data is not equal to null, what you have to do? So system dot out dot println of that temporary data, temporary node is there, right? On that, what data we have, I am printing. That's all. Sir, how to go to next node? Sir, immediately what will happen? Temporary node is equal to, so temporary node dot next means what? Next time it will point here. Next time it will point here. Sir, next time, what is the node that we have? Null, right? So then, is this condition is not satisfied, it will come out from this. So I'm using temp is equal to, sir, temp dot next life. That's all. So at the end, anyway, we have null will be there, right? Just for our understanding purpose, I am printing null. And here also, I don't want ln, just I want to print in the style of linked list. That's why I'm taking like this. Sir, what will be the output of this program? So initially, so where temporary node is pointing to? What is a temporary nodes data? 2, right? 2 is the temporary nodes data. Sir, then it will take space and then like this. Next temp is equal to temp tends to next 5. Sir, next space followed by like this. Next data is the next data is nothing but we don't have any data. That's why it is going to print null. In this style, sir, I'm going to get the output. Okay, because if it is the list, if the list is going to change, everything will change. Sir, how this retrieval is happening, I think it is very clear for you people. Now, again, I am repeating, sir, please concentrate well. So initially, I am going to check is head is equal to null. No, this is the head node, which is not equal to null. Okay, one second. So here the last node will be always null. So your head node is not equal to null. So what will happen? Node, we are creating some temporary node. Okay, we are creating some temporary node. So temp is equal to head. Wherever head is pointing, same node is pointed by temp. Sir, while temp is not equal to null. Yes, it is not equal to null. So it will print temp tends to data. What is the data that we have to followed by some arrow just for stale purpose. So temp is equal to temp tends to next. What is the next field to the temp? This one. Now temp is pointing to this one. This link will be gone. Now is it equal to null? No, not equal to null. So print temp tends to data 5. So now give the arrow mark. Now temp will become temp tends to next. This link will be gone. Now it will point here. Sir, is it not equal to null? Yes, print the data. Sir, next temp is equal to temp tends to next. This link will be gone and it is pointing to null. Sir, is it not equal to no? No, it is not equal to null. This while loop is failed. It will come out from this and just it is printing for our understanding purpose null. It will terminate. So this is the way how we can able to print a linked list, sir. Can you please confirm, is this concept is clear for everyone? I request everyone to please respond. Is it clear? Anul Anil Ansari, he is asking one beautiful question. Sir, why you are not using head instead of taking temp? The head is the only pointer which we have. If you shift the head, what will happen? Next time when you are inserting, this will become head because head is the only pointer. Okay. Yes, yes. Head is the only pointer to point the entire list, like array name. Okay. Clear? Yes. Can we print insertion order? Yeah, this is already in insertion order only, right? According to the order only, it is printing. We can't perform sorting all these things. It is a difficult task, right? Now, sir, I want to execute this code because I think we have never executed this linked list program, right? We need to see, is there any technical mistakes are there? We have created a new linked list. So before adding these items, okay, before adding these items, if you print the linked list, what it is a printing? I think it is a printing the message is saying the list is empty, something like this. It is printing, right? I didn't check. Yeah, list is empty. Now I want to add one item. Now I want to see the list. Have a look once. What is the item that you have added? Triple three. Is that a triple three came? Yes, sir. But still it is printing list is empty because at the very beginning you have printed list. I think this is not required now. Sir, I have added one item so that that item will become the first item. Next item will become null. Okay, three and then triple three and then null like this. Sir, I'm removing this. So what I'm expecting, add first, right? In the beginning only that triple two is going to be added, right? Sir, I want to add one more item. No problem. Sir, where it is going to be added? At the beginning only it is going to be added. Let us cross check. Yes, perfectly it is working. Now, sir, I want to perform add last option. Okay, add last. Add last means what? We have to add at the ending, sir. So if you want to add at the ending, some exercise we have to do. Okay, so same program. Sorry, one second. So add function, add first is there, right? I have to change it to add last. Sir, some algorithm we have to apply here. What is that algorithm? Okay, let me check again. So node, new node is equal to, I'm going to create a new node. Yes, okay. So if head is equal to null, your head will become that new node. Since if you have no elements, common operation. Okay, suppose if your head is not equal to new node, then what we have? So in the beginning, what I have performed, suppose already we have triple one is there. Next node is triple two. So next node is triple three. Like this we have, right? Next node is null. Like this we have. So this is nothing but head. Now, if you want to add at the beginning, just we will create the node and next is pointing to this one and this data is going to be head node. Like that simple steps we are trying. But now that is not the case. I want to add at the last. So if I want to add at the last, what we have to do? You need to move the pointer to the end and this node is there, right? This next node you have to point to this and this next node will become null and by default this link will be gone, right? We have to do this big step. So for this, so we have to move, okay? We have to traverse to the linked list to check the next element is on. Yes, correct, Vishal. So we have to keep on moving to the ending. Sir, how to move this? As usual, we have seen, right, in the previous example, if you observe, we created one temporary pointer. Initially, it is this one. So next this one. Sir, next this one. That's all. We have to stop here itself. We should not go to this. We should not go to this. We have to stop here itself. So a beautiful logic I am applying for that. What is that logic here is, listen carefully, sir. What is that logic I am going to write here is, listen. Sir, these two statements I am going to remove. So as usual, I am going to create node, some temporary node. This temporary node is nothing but head. So while I'm not using temp is not equal to null. I'm not using temp is not equal to null. I'm going to take temp dot next is not equal to null. Okay, so means what? Sir, observe carefully in the diagram. Means what? Observe carefully in the diagram. Sir, initially I will maintain one temporary node which is pointing to this head node. Now, is this next field is not equal to null? Is this next field is not equal to null? Yes. Now move this temp. Sir, is this next field is not equal to null? Yes. Then move this temp. Is this next field is not equal to null? No, this field is null. So we have to stop here itself so that we can identify this is the last element. Now last element next will become head, last element next will become new node or not? Yes, that you have to do here. Sir, how to move this pointer? Very simple. So temp dot, okay, sorry, temp is equal to temp dot next, like this we are keep on. At the end, sir, I'm going to take temp dot next. Temp dot next will become that new node. Temp dot next will become new node. Sir, no need to assign the null pointer because automatically it will be there, right? That's why. So I think this while loop is having only one line. We can read that. That's all. Okay. Now, first, let me execute. I mean, let me explain again by taking the diagram. Listen carefully. So I have one node is there already. Some nodes are existed. Consider this is the first node we have, and this one is nothing but the second node we have, and this one is nothing but the third node we have. I want to insert one node. Let it be considered that node is nothing but 444. I want to add this. Okay. Now previous node is what? Null, sir. Right? Now this node name is nothing but what? A head. Like this we have. Now I'm going to maintain a pointer. I'm going to maintain a pointer. What is that a pointer? Sir, temp is equal to head. So my temp node is pointing to head. Okay. Now, sir, temp tends to next. Temp tends to next is nothing but this node. Is it not equal to null? Yes. Move the pointer. Sir, temp tends to next. Is it not equal to null? Yes. Move the pointer. Sir, temp tends to next. Is it equal to null? Yes. Then come out from the while loop. What is your temp is pointing now? These two links will be gone. So temp is pointing here. Now what we are doing? This next node, I am going to erase that link and I am going to point this one will become like this. Anyway, while creating this new node, this is new node, right? While creating this new node, your next field is null or not? Yes. So that temp dot next will become new node. Like this, I am taking by default, this link will be gone. Okay. Now, just for your reference purpose, I am deleting all the links. That's all. Now assume I want to create one more node, like I want to take a 555. So this is the new node, right? And the new node next field is pointing to null. Sir, what you are doing here? So we have to create one temporary node which is pointing to head node. Sir, is next field is null? No. So temp will move here. This link will be gone. Sir, is it next field is null? No. So it will move here and this link will be gone. Is it next field is null? No. Then move to this and this link will be gone. Sir, is this next field is null? Yes. Now temp is pointing here. Temp tends to next will become new node. So temp tends to next means what? This one. This next field is nothing but new node. Okay. Now automatically this link will be gone and these links also will be gone. That's all. Sir, is a perfect linked list is prepared or not? Yes, like this. So, but it is a risky, right? When you are adding at the end, you have to traverse the entire list. Like this we have. Sir, if you are clear with this, I will execute this program. Can you please confirm? Technically, do you have any doubts up to this? Please respond, everyone. Right, sir. So now I want to execute this code. Sir, what is that execution? I want to add. So list dot add last of. Let us add 444. Then list dot add last of. I want to add 555. So list dot add last of. So I want to add 666. Like this I am taking. So what will happen after this? I am going to get 444. After this, I am going to get 555. After this, I am going to get 666. Let us execute this program and see what happens. Okay, perfectly is the items added or not? Suppose consider I want to add 999. If you use add first of 999, so is the item is going to be added at the beginning or not? Yes. So if you use add last, is the item is going to be added at last or? Yes. So I think how you can able to perform insertion, insertion at the beginning, insertion at the ending, and printing the linked list. I hope these concepts are very clear for you people, guys. Can you please confirm? Do you have any doubts up to this? Clear for everyone? Please confirm. We will see. We will see. Definitely. Okay. Right. Right. Sir, I want to perform the basic delete operation. Okay, I want to perform the basic delete operation. Like void, I want to take so delete first. I think argument is not required. Similarly, I want to take so delete last. These two functions I will implement now. Suppose after this, okay, after this, if you ask delete first, which item it has to remove? 111. If you ask delete last, 666. Let us see the code first. Okay. So I want to write code for delete first. Sir, it is a very easy. Nothing is there to think. Okay. Because if you have elements like so 11, so 12, okay. Next and after that 13, next and after that 14. So consider next element is null. Like this, if you have, this is the head node, right? Sir, how you can able to take? Your head node will become head node tends to next. That's all. This link will be by default gone. Anyway, while printing, from where we are printing? From this head only, right? So that by default this content will be gone. That's all. Okay. But if it is a delete last, what we have to do? We have to do some major operations. Okay. So now I will write code for that delete. First, it is very simple, sir. But before that, we have to check array is my head is equal to null or not. You have to check. Suppose if your head is equal to null, then what we have to do? So system dot out dot system dot out dot println of I am telling so list is empty and then return terminate. Otherwise, what we are doing? Your head will become okay. Your head will become so head dot next. That's all. No need to destroy that. Automatically, it will be gone. Okay. Now I want to execute this code. Sir, can you please delete? Add sorry, delete. So first, like this, I'm calling. Is that triple one will be deleted or not? I want to check. Let's execute the code. Sir, before this is nothing but my linked list. Okay. Sir, from this, is this element got deleted or not? Yes, perfectly this element got deleted. Okay. Sir, now delete first is working perfectly. Now I want to take, so delete first again. Okay, I want to take delete first again. So what will happen? This triple two will be again deleted. Okay, this triple two will be deleted again. You can able to see like this. Okay, so this is nothing but how to perform delete first. Okay, now I want to implement a delete last. But before moving to that, can you please confirm everyone? Is this a delete first function? Is it clear for you people, guys? Please respond.
Yes, sir.
Right. Sir, next one is very dangerous. Please concentrate well. Delete last. So what is this delete last? Listen carefully, friends. There are multiple cases are there. Sir, first case, as you know, suppose if your head pointer is null, then what I'm going to do? So I will print the message saying my list is empty. List is empty, something like this, and I will return. Sir, there is one more condition that you have to evaluate. What is that condition? For example, consider my list is nothing but a triple one, and the next node is null. That means I have how many nodes are there? Only one node. If you have only one node, then what you have to do? Sir, you have to delete this entire reference, right? So that is nothing but one case. Okay. So in the previous example, what we are doing? Head tends to next we are pointing. So head tends to next is what? Null. But here we are not using head tends to next. That's why you have to implement it manually. Suppose if your head dot next, that means next field is equal to null, means this is the only node we have, then immediately you have to maintain head is equal to null and then return. This is one special case what we have. Suppose this is not the case, sir. Okay, this is not the case. I have some elements are there like 11, and then I have 12. Okay, and then I have 13. Okay, and then I have 14. Like this, we have certain elements are there. Last node is pointing to null, and this node we know head. Sir, is head tends to next is null? No. Now, listen carefully. We have to perform some activities. We have to perform some activities. So what is that activity is? Just to understand, sir, please clearly understand. So I will maintain, okay, I will maintain, so temporary node. Okay, temporary node is nothing but this one head. Temporary node is nothing but this one head. Okay, like this I will maintain. So next term, what I am going to do, sir, is this a temporary node next field is there, right? So this is a T1. Again, I will maintain one more pointer T2, which is pointing to this one. Okay, head tends to next. So the first pointer is going to point to head node. Second pointer is pointing to next node. Now, until this node, last node is there, right? T2. Sir, T2 next field is null. Until that, you have to move T2, sir. Sir, now what will happen? Your T2, this pointer, we are moving to this one. Okay, next immediately you have to move T1 also. Okay, you have to move T1 also. Now where T1 is going to point? This one. Like this, you have to move to 2 pointers. Now, sir, is T2 tends to next? Is it equal to null? No. Then again move T2. Sir, now this T2 reference will be gone. Now again move this T1. Okay, again move this T1. This T1 will move here. Okay, sir, now this link will be gone. Now, what is the next step? Sir, is T2 next field is null? Yes, the next field is null. So it will come out from the loop. Now, what we are going to do? Sir, this one is there, right? T1. So T1 next field is pointing to null. T1 next field is pointing to null. T1 next field is pointing to null. Like this, we will set. So that what will happen? Sir, this link will be gone, because once if you assign to the null, then this link will be gone, this link will be gone, all these things are erased. That's all. Sir, then why you are maintaining 2 pointers? Why you are maintaining 2 pointers? Just to hold previous value, sir. Just to hold previous value. Because how many steps you have to move? Last before step you have. That's why. Okay. So how you can able to point this node? Next is not equal to null. How you can point this node? No, right? It is not possible. That's why. So to maintain these two things, I am taking two temporary nodes. One is pointing to the last one. Second one is going to point to the last before, so that last before node next will become null, so that we can stop. Okay, sir, like this it will be concept. Now I want to write this technically. How to write? Node, how many nodes you have to take, sir? Two nodes. Let it be so temp1 and then temp2. Two nodes I am taking. Sir, your temp1 is pointing to head node. Your temp2 is pointing to which one? Head dot next. Excellent. Now you have to move both the pointers, but here target is temp2, right? Until temp2 next is not equal to null. Okay, so what activity we have to do? Two movements we have to take. The first one is what? So temp2. Okay, temp2 dot next will become, sorry, temp2 will become, so temp2 dot next pointer. Similarly, your temp1 will become temp1 dot next. Just we are moving the pointers. Once if the last node next field is null, then it will stop. So which one is the last before node? Temp1, right? So your temp1 dot next will become null. Like this we are taking. Okay. So temp1 dot next will become null. That's all. There ends the matter. So let us execute this code. Really, is it happening or not? Let me run this code and I will show you. Sir, in the program, delete last, I think we have not taken. Let me take, so delete last. Once if you take delete last, what will happen? That item is going to be deleted. Which item? 666 will be gone if I am not correct. Right? Deleted or not? Yes. Smoothly you have to write the code, sir. Otherwise, the complete thing is going to be disturbed. Now you have to take delete last. Which element it is going to remove? This 555 will be gone. Let me check. Yes, perfect. Sir, again, if you call list data delete first, again, if you call list data delete first, sir, what will happen? 444 will be gone. 444 will be gone. So again, if you ask list data delete last. Okay. So delete last. Sir, what will happen? So I think here we have taken first. Here we have to take last. Sir, which condition is this one? Have you observed this case? Only one node is there. In such cases, what will happen? This will be pointed and it won't print null. I think it will print the message saying list is empty. Yes, like this we have. Sir. So I hope you people got very clear clarity about so how we can able to delete the entries from the list. Okay. So I hope both the cases are very clear for you guys. So yet I didn't introduce linked list, just the basic operations, how you can able to perform on the linked list, just I demonstrate. Can you please confirm clear up to this? Okay. Anyway, so in detail, again, we have a linked list, beautiful concepts are there. So we will talk about that in the Monday session, sir. Anyway, tomorrow we have the class. I already scheduled the same link you have to use. So tomorrow strings I am going to take from 8 p.m. to 10 p.m. Okay. Don't miss tomorrow's class. 8 to 9 tomorrow I am going to take the strings. If anyone is unable to attend the class, you can watch the recordings. Okay. Right, sir. Tomorrow and the day after tomorrow, we have class from 8 p.m. to 10 p.m. The syllabus which I am going to take is nothing but strings. The complete strings concept we are going to discuss. Okay, sir. Thank you. We will meet for a
Sir, hello,
continuation on
hello,
Monday for regular class, and
sir.
tomorrow special class is there. Sir, please wait. Yeah, tell
uh,
me.
Sir, I have a question. For how long we can access the recorded videos
7 months.
after?
7 months, sir.
Okay, okay, okay.
Okay,
Thank you, sir.
okay, sir. Right.
And sir, uh,
Uh,
sir, can
because
you add me on WhatsApp group, sir, please?
Yeah, I will add because I need to get confirmation from admin team, sir. Whatever message you are posting to me, I am forwarding to admin team. Once if I get confirmation, I will add you. Okay.
Yeah. So, sir, what I can do for that?
No. You have already sent message to me, right?
No, sir. I did not because I don't have your number.
Sir, I have shared that number in chat window. Please cross check. Sir, I am closing the meeting because I have another meeting immediately. We will discuss remaining things in the next class. Thank you.
Okay, sir.